Today we're doing the real number system. We've talked about rational numbers before. It's any number that can be written as a fraction. All right, whole numbers, integers, decimals like repeating decimals or terminating decimals. You can write those as fractions. Now we're going to add to it. We're going to talk more about rational numbers. We're also going to add irrational. Rational numbers, it's numbers that can be written as fractions. Like I said, -4. Can I write -4 as a fraction? Yes, I write it over 1. Can I write 0.15 as a fraction? Yes. Remember, this is in the hundredths decimal place, so I just write over 100. We've done that before. This is what we're adding. Irrational number. A number that cannot be written as a fraction. This is pi, and this symbol means it's roughly equal to, it's close to 3.14159, and it continues on. It's 265358979, and it goes on. It doesn't end. It doesn't repeat. It doesn't have a pattern. So we consider that an irrational number because we cannot write that as a fraction accurately. What a lot of people do will write pi, or when they're calculating pi, they'll just times by 3.14. Calculators go to, I think, 535, I think around there. But you can't accurately display it or you write it as a fraction. You can drop off and go 3.14 and write 14 over 100. You can do that. But will it come out exactly like this? Where it's 3.14159, 265358979? No. Right? Pi doesn't end. It goes, there's millions and millions of digits. Okay? It takes supercomputers to figure out those numbers, how much longer it goes. Because it doesn't end. It doesn't have it doesn't repeat. If you look up there, there's no pattern up there. It's random. It's random every time. Each number is random. Right? The square root of 5 is kind of like that. It gives you 2.2360679 and on. Doesn't have a pattern. It doesn't repeat. It doesn't end. Right? It's a random number like that as well. So it can't be written as a fraction accurately. You need to copy this then. Alright, this is a set of rational and irrational together. They come up to make a set of real numbers. Okay, pretty much every number you'll work with this year is a real number because it includes rational and irrational. The only other type of numbers beside real numbers is imaginary numbers, like infinity or negative infinity. Alright, you won't work with those. You'll work with just real numbers. So when I talk about real numbers, it could be a rational number, it could be irrational, right? I've made this diagram so today in your homework, when it asks you to identify the sets of numbers that number belongs to, you can look and know exactly what it belongs to. If it's a rational number, it can be written as a fraction. That includes numbers like 1/4 and 0.2 repeating. Remember, a repeating number, a repeating decimal can be written as a fraction, 2 over 9. Like this can be written as a fraction. Also, integers, they can be written as fractions, so they're considered rational numbers as well. -6, -3, negative square root of 25, which is -5. All right. The integer, remember the group's integers I told you? It's 0, 1, 2, 3, 4, 5, and on. It's also -1, -2, -3, -4. It's whole numbers with negative signs. That's integers. It also includes whole numbers, which is 0, 1, 2, 3, 4, 5, and 6, and on. Right? So if they said identify 0, you would say it's a whole number. You would say it's an integer. You would also say it's a rational number. If they said identify 1, it'd be a whole number, an integer, and a rational. If they said identify -6, it's an integer and it's a rational. Does everybody see a pattern here? Yes. Right? The bubble it belongs to and out. Right? -6 belongs to the integer bubble. It also belongs to rational numbers. If they said 1/4, it's just rational. Alright? Any questions so far? Alright, write this down. Alright, this is a lot of what your homework's going to say. It's going to say name all sets of numbers to which each real number belongs. 21 over 7. What does that reduce down to? 3. Here's the question you always ask when you're identifying this, because it either makes it a rational number or irrational. Can this be written as a fraction? Yeah. Yes, obviously it was a fraction. So it's rational. It's a rational number. Then you go on. Is it an integer? Does it fit between -1, -2, -3, 0, 1, 2, 3? Yes, so integer is included. Then you think, go to the smallest bubble. Does it belong to whole numbers? 0, 1, 2, 3, 4, 5, and 6.
Yeah.
So it's a whole number as well. Work yourself outside in from those bubbles. All right? Outside is the least descriptive. It's and then the farther in you go, the less numbers fit in those bubbles. Okay? -2.5. Always ask yourself first, can this be written as a fraction?
Yeah.
So it's rational. Is this an integer? Does it belong to 0, 1, 2, 3, 4, 5, and -1, -2, -3, -4, and on?
No.
No, this has a decimal, or you could say it has a fraction. Integers don't have those. It's whole numbers with negative signs. Does whole numbers have decimals? No. 1, 2, 3, 4, 5. Integers are -1, -2, -3. So this is just rational. That's it. What about 0.2 repeating? Can this be written as a fraction?
Wait, fraction, yeah.
Yes, I use this as an example in your bubble for rational. You can always write repeating numbers as a fraction. I've showed you how. You always write it over 9. Good. So 0.2 repeating would be 2 over 9. If you don't believe me, check your calculator. So, is this rational? Yes, because it can be written as a fraction. Is it an integer? No. Is it a whole number? No, because it's got a decimal. Square root of 38. All right. What do you guys think? Rational or irrational? Can it be written as a fraction?
I think it's irrational.
No.
Let me read it to you. 6.16441440 and on.
Irrational.
Okay? It does not end. Does it have a pattern? Was there a pattern there?
No.
No. So it's irrational. Because it cannot be written as a fraction. All right, this is another type of problem you're going to see. It's going to solve. You've got a squared equals 36. You need to figure out what a is. Right? If it's a squared, what I want to do is I want to get it to where it's just a. Where it's just a equals. Here's how I do that. If it's squared, I can square root it because it's the opposite sign of squared. The square and the square root will cancel itself out. And all you're left with is the base, which is a. But what I do to one side of the equation, I always have to do to the other. So now I figure out what is the square root of 36. Someone raise their hand and tell me. Kobe. It is 6. Someone else raise your hand and tell me what else can be the square root of 36. We talked about the other day. Caitlin. 2? No. 2 times 2 is 4, right? What was it? You don't remember? Kyle? It's -6. It can be +6 or -6. Good, Kyle. Because what is 6 times 6? 36. What is -6 times -6? 36. Does it say, is it written out where A is positive? Is that written out? Okay. Does it say A is negative? So I have no idea which one it is, do I?
No.
So A could be positive or -6. That's why I taught you the other day about this symbol right there. Positive or negative, plus or minus. Because it could be either. Right? I don't know which. So I give you both. Alright? Write that down. We have 2n squared equals 170. This is just like what we've done before. We're trying to figure out what n is. It'd be just like if this was 2n equals 170. Someone raise their hand and tell me what I would do to get n. If it was 2 times n equals 170. Gaddy? No, if I'm just doing this right here. Beagle?
Take it off both sides.
By dividing it, right? Dividing 2?
Yeah.
Okay? So, what I want to do here is I want to get n squared by itself. Alright? So, I do that by dividing both sides by 2. Gives me n squared. Someone raise your hand. Tell me what 170 divided by 2 is. You don't need a calculator for this. 85. Good. Now, what I do to get n by itself, remember my goal is always to get n by itself. So, Gowdy, what would I do to make n squared n? Square root it. They cancel each other out. Square root and square root are the opposites of each other. Okay? So you have n. The square root of 85 could be positive or negative. I'm not for sure. Now, if you had a calculator, right, you would do square root of 85. But for the OCCT, they don't give you a calculator. So what they'll do is they'll let you answer it in this way. Plus or minus the square root of 85. Because if you had a calculator, you would get positive or negative 9.2. Roughly 9.2. Isn't that the same thing as the square root of 85? So when you don't have a calculator on hand, you can write it like this. So I will take this, or I will take positive or negative 9.2. I prefer it like this because I want you to see it. I want you to get used to answering like this, because the OCCT will have answers like this. Because they don't let you use a calculator. So they let you stop at this point. Because if you had a calculator, you would know. But it's not that important. That's why they stop here. Write this down. And you solve it. 363 equals 3d squared. What you always want to do is get the variable by itself. I do that by dividing by 3. 363 divided by 3 is 121. 121 is equal to d squared. So I square root both sides. Right? So d is equal to positive or negative. What's the square root of 121? 11. So there's the numbers I was looking for. Here's your homework assignment for today.